Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture today, I will describe or discuss some definitions and their meanings or the terminology on the topic Beyond Classical Search, which is our module 1 on the course Applied Artificial Intelligence. This is the course outcome. After the completion of this course, students can discuss the appropriate search strategies and knowledge representation techniques to implement inference mechanisms for AI-based problem solving. Okay, so here few definitions I will discuss related to Beyond Classical Search. So this is the first term. What do you mean by the objective function? The objective function, it is called as a mathematical function, or it is a mathematical expression that quantifies the quality of a solution. The goal of the local search is to optimize, that means maximize or minimize this function over a continuous domain. That tells us how good or bad a possible solution is. So objective function, first of all, as the name it implies, it is a function. The function can be represented with the help of mathematical formula. The function may be y is equal to mx plus c, okay, or else any other formula that depends upon the space, whether it is linear or non-linear. So objective function, what it says, especially this type of functions are used in the local search techniques where we used to explore the best possible solutions or the optimal solution. That is why objective functions helps us to find out whether the scoring value is a good solution or a bad solution. If it is a good solution, it is well and good. If it is a bad solution, it will try to explore the new neighboring solution which is better than the previous solution. So that is why the objective functions are required. Now the next term is continuous spaces or continuous space. Continuous space is a domain where variables can take any value within a range, typically represented by the real numbers. For example, adjusting the temperature of an air conditioner. So as the name it implies, continuous space, like the space would be continuous in nature, where the value will be continuous. Okay, continuous means we can take the example of the real numbers, maybe 0, 1, 2, 3, like this we can consider, like these are the real numbers which are continuous in nature. Here one of the example I have given, adjusting the temperature of an air conditioner. Like if you want to set the AC temperature between 16 degree to 29 degree, we can write 16 degree, or we can write 16.1, we can write 18.2, we can write 19.5, we can write 28.5. Like this we can assign many real number values between 60 to 29 degrees. So these values are continuous in nature, and these values depends upon the room temperature only. So that is why continuous space is a domain where the variables can take any value within a range, typically represented by the real numbers. If you compare with a discrete space or discrete value which takes the fixed values, if I say the AC temperature, it is in the discrete range between 16 to 29, that means it may be 16, it may be 18, it may be 20, it may be 22, and so on. These fractional values will not be considered in case of the discrete space. Then the next term is local search. Local search is an optimization technique that iteratively improves a solution by exploring its neighborhood in the search space. So basically the local search is not like our informed search or uninformed search. Local search techniques, that is why local search technique, it comes under beyond classical search. And this local search is used for optimization technique where we can explore or we can find out the best possible solution among all possible solutions within a short span of time, and how this optimization technique can be applied by iteratively improving a solution. That means, suppose for example, the agent starts at, so that is why the local search technique or the objective function which we define for the local search it takes the solution at any point of time or any random solution it takes, then it tries to find out what is the scoring value at this point. And if the scoring value is good, then it is well and good. If it is not good, it tries to improve its scoring value by exploring the neighboring points. So either upward direction or else downward direction. So if the upward direction neighboring scoring is better than the previous scoring, then the neighboring scoring will be considered as the current score. So like this, it tries to improve the solution over a period of time to find out the optimal solution. The next term is search space. Search space is the multidimensional domain of continuous variables within which the algorithm searches for an optimal solution. The space where the continuous values remain, that is called as the search space. Now, if you take the example of the same AC temperature, we can range, it may range between 16 degree to 30 degree, and the fans, this is the AC temperature, and the fan speed we can take suppose between 1 to 5. Okay, so how we can assign these two values together in multidimensional space? If I take only one example, then we can assign in a single dimension. We are taking two things. One is the AC temperature, another one is the fan speed. That means I can assign for AC temperature 16 degree, the fan speed may be 2. For the AC temperature 18 degree, the fan speed may be 3. So like this, we can assign the values together, both the values together. So that this is the representation of the multi-dimensional domain. Different real number values we can assign together. Okay, so within which the algorithm searches for an optimal solution. Now come to the step size. What is step size related to beyond classical search? Step size is the magnitude of each move or adjustment made to the current solution during each iteration or during an iteration, influencing the convergence speed and stability. Now, as I told in the local search technique, local search starts at the random solution and try to improve its solution gradually to find out the optimal solution. So each movement, either it will move, so each movement from one location to another location and from this location to this location, how much movement is done, that is called as the step size. Okay, the step size is very important in case of the local search. The step may be very low or the step may be very large. The step, if it is very small, then smoothly it will cover the space and it will find out the optimal solution. If the step size is too large, in that case, sometimes it may miss the optimal local minima also. In case of the hill climbing, you might have known what is called as the local minima. So if that depends upon the step size. If the step size is very small, then there is a gradual movement or there is a gradual exploration of the space so that the optimal solution can be easily found out. But if the step size is too large, then sometimes the local minima means that if the space would be like this, then local minima point will be missed. That is why step size is very important. The value of step size which identify the value of the objective function. Now, what is the meaning of non-deterministic actions? Non-deterministic actions are the actions whose outcomes are not guaranteed, leading to multiple possible states. So as the name it implies, non-deterministic. If the outcome of every action cannot be determined in advance by the agent, that is called as non-deterministic action. And for each action, several possible multiple states can be generated. For example, if I take the example of the robot will move from the point A to point B. But while moving from A to B, either it may move from A to B, that is the final goal, or else while moving, it move up to half of the way, then the wheel is broken, something, then it gets stuck here. That is another solution. Another way, another possible solution is the robot may not work or the sensors does not work to perceive the information from outside. Anything can happen, but the target was for the robot is to move from A to B. But to perform this movement action, here just I have given one example. 3 possible states may happen. There will be n number of possible states may happen. So that is why non-deterministic action says that if the outcome of the each action cannot be generated or cannot be predicted in advance by the agent, then that is called as non-deterministic actions. Then contingency plan. Contingency plan, it is a backup strategy to handle all possible results of non-deterministic actions to achieve the goal. As I told just now, non-deterministic action where the outcome of the actions cannot be predicted or cannot be determined in advance by the agent. So to handle that uncertain situation, some contingency plan is required for the agent, means backup strategy. That means, as I told, the target was the target for the robot was to move from the location A to B. As there are three different actions I told, like either it can move from A to B, it is well and good, means target is reached. If it or else the target, suppose the robot will start from A and half of the way it will move, after that the wheel broke, then it cannot move, or else some other thing, it uncertain situation may happen, sensor fails or some other things fails, or the arm broken, then in that case also movement will not be done. So for every action, some contingency plan, if it cannot move, for example this path, if after certain movement, if the wheel is broken or some unwanted situation happens with the agent, some alternate path or alternate solution would be there. That alternate solution is nothing but the contingency plan. It may move back to the original step, then it may take some other path to reach the destination. Like this, some other solutions would be given. So solutions to handle the uncertain things, that is called as the contingency plan, which is used for logical agents. Now, outcome set. What is the meaning of outcome set? Outcome set is the collection of all possible results from a single non-deterministic action. So, whatever the results we used to get for the non-deterministic action, all uncertain actions, that combination of all the results are called as outcome set. Now, just now I have given the example. Now, robot will move from A to B. That is the well situation. This is one outcome. Robot will move, but after moving the halfway, wheel broke. That is another action. So first action we can represent with X. Another action we can represent with Y. And third action, it could not able to start the progress. So that can be represented with the help of set. So like this, all possible actions we can write with the help of set operations. Now, what is partial observability? Partial observability is a situation in which the agent does not have complete knowledge of the current state, complicating the search process for non-deterministic actions. So here, partial observability, especially this is one of the situation we face in the case of beyond classical search. Especially if you take the example of the robot or drone, sometimes this situation happens. Like for self-driving car also. So when the self-driving car moves on the road, for its visibilities up to certain range, the sensor works like up to 50 meters or up to 100 meters. Beyond that, it may not work or does not work. Okay, so up to 100 meters, it can like judge where the obstacle is, where the person is, and accordingly, it will take its right action. If you take the example of the robot like who works in the foggy environment, that also it is called as the partial observability, where the wall is present, where the obstacle is present, it will not be known to the robot in advance. So it has to move and it has to explore and it has to adapt to the situation. That is called as partial observability, where the agent will not have the complete information about the search space or about the environment. Partial information would be there, and as and when the agent progresses, it has to explore and adapt to the situation. Now, what is the meaning of backtracking? Backtracking, it is a method of revisiting the previous decision point when a specific sequence of actions does not yield the desired goal due to non-deterministic action. So when we move back, if we cannot reach the goal state, that is simple way, in simple English we can say, when we cannot achieve our goal, then we used to move one step back or two steps back, then we used to find out new solution from the original path. That concept is also used in case of the beyond classical search for the logical agent, revisiting the previous decision point so that if the sequence of action does not find or could not able to find the desired goal. Next one is the online search agent. Online search agent that performs the action without the prior knowledge of the environment, learning and adapting in the real time as it explores and interacts with the environment. Why the name is called as online and offline? What is the meaning of offline? So online means where the agent does not have the complete information about the environment. That is why the name is called as online environment. So if the agent works in online environment, then agent has to learn, agent has to explore, as well as agent has to adapt to the situation to interact with the environment. Like for example, here I have given a cleaning robot in a new house. So when we purchase one robotic vacuum cleaner without its configuration for our layout of the house, initially when it starts to work, it has to explore the path, explore the free path, so that it can clean the floor efficiently. So that exploring and knowing that where the obstacle is present means adaptability, self-learning and self-adaptability. That is why this type of search technique is called as online search, and the search which is defined or which is done by the person or the agent, that is called as online search agents. Then what is unknown environment? Unknown environment, it is a scenario in which the agent has no prior information of the states, transitions or the outcomes. It requires the exploration to gather information and devise the strategies. I mean, the complete information is not known to the agent. If you take the example of the search and rescue robot, or if whenever we are sending the drone has to learn the environment and it has to explore the situation. Same thing, the search and rescue robot also, when we send to the disaster environment where the earthquake has happened, then it has to explore the victims and the person and the walls, then only it can handle the situation. So those environments are called as unknown environment, and that is not a topic actually, it is a scenario, it is a situation in which the agent does not have the complete information before exploration. It has to, as and when it move forward, it has to learn, it has to explore the situation. Then what is the meaning of learning agent? The agent who can learn. If you consider ourselves also, we are the human agent, we can learn and we can adapt to the situation. Same thing in the field of artificial intelligence. Learning agent is an agent that improves its performance over the time by accumulating the knowledge about the environment through the exploration and experience. Okay, so as I given just now, I have given the example for the robotic vacuum cleaner. That also we can consider as a learning agent. Initially it doesn't learn anything, it doesn't have any knowledge. It has to be trained by the owner of the house. What is the layout of your home, where the object is present. So if we give proper information, if we configure it, then only the robot can work to clean the floor. So learning agent, they have their performance, they can learn the environment through their exploration, as well as they can adapt to the new situation also. Next, what is the meaning of frames? Frames are the structured data formats that represents the stereotypical situations. They include slots and filters to store the domain-specific knowledge. So especially frame is nothing but it is used to represent the knowledge inside the knowledge base for the expert system, and which can represent the stereotypical situations, means the situation which is of similar type. Now if I take the example of the students information of our class, then all the student informations means the student name, their IDs, their marks, average marks, percentage, everything we can store in a particular table in the form of rows and columns. And while inserting the values in the form of rows and columns, the attribute which we write at the first row, they are called as the slots, and their respective values are called as the filters, or which are called as the facets also. So frames are the fundamental rule which we use to represent the knowledge inside the knowledge base. Then what is ontology? Ontology is a hierarchical framework that organizes the entities, categories and their relationships. It provides a shared vocabulary for consistent knowledge representation. Why it is called as a hierarchical framework? Because it represents the entities, categories and their relationship. Entities, it may be the class or it may be the subclass and their attributes. There are different types of classes, means categories, and the relation between the class and subclass. Everything we can represent in the form of restructured. That is why it is represented as, it represents the hierarchical framework. So it provides a shared vocabulary for consistent knowledge representation. So ontology is a type of knowledge representation technique like other techniques, frames, or semantic networks, where the knowledge can be represented in the form of hierarchical framework using class, subclass, and their relationships. Next, what is the meaning of an agent? An agent refers to an entity that can perceive its environment through the senses and act upon the environment through the actuators for or actions. So agents are designed to achieve the specific goals or perform the task by processing information from their surroundings and making decisions based on that information. So here agent, you can consider yourself as an agent, or else you can consider robot as an agent. So agent will have the sensors and actuators, two important components. Through the sensors, the agent can receive the information from the environment, and through the actuators, it can perform the action to the environment. If we think about ourselves, then we have 5 sense organs. Through the sensors, we receive all the information and it goes to our brain. Then brain process the information, and accordingly we used to behave, means we act with the help of our legs or hands. That acts as an actuators. And the same thing happens with the robot also. Those which are called as the logical agent, they can, or maybe here the agent may be a software, agent may be a software application, or it may be a AI program we can say, or it may be a robot which is having the capability to receive something from the environment through the senses, and it will have the capability to reason, to understand about the information, as well as it can perform the action through the actuators. Now the next term is proposition logic. Proposition logic is a logical system where the statements are considered either true or false. So few logical connectives are used like and, or, and not. So like and, we used to use like this, or symbol, this is your or symbol and this is your not symbol, which defines the relationship between the proposition. So for example, if I take like I like apple and I like banana, so I can write, if I like apple X and banana is Y, then X and Y, I both like banana as well as apple, so X and Y. Okay, so like this, the representation can be done. The knowledge or the English sentences can be represented with the help of these connectives. Next, what is simple reflex agent? A simple reflex agent is a type of agent in artificial intelligence that operates based on a set of condition and action rules, also known as the production rules. It reacts to specific situations or inputs from its environment by performing predefined actions. And this type of agent does not have memory of past actions or states and makes decisions based on solely on the current perception. So simple reflex agent is one type of agent we can say, which consists, this is one agent which can perform the action, but how it performs the action? By considering some rules. Those rules are called as the production rules. And what type of rules? It accepts the current situation rules, does not accept the past memories or past facts. It receives the information from the environment based upon the information which are defined with the production rules. Based on that, it performs the action. That is why they are called as simple reflex agent. Then what is knowledge engineering? Knowledge engineering is the process of designing, building, and refining knowledge-based system. It involves domain analysis and encoding the expert knowledge. So knowledge engineering. So it is not a simple word. The knowledge, especially this knowledge engineering technique, it is used to build the expert system. Already I have discussed in my previous video. You can watch it. What is expert system? What are the important components of the expert system? So one of the important component of the expert system is the knowledge base, which requires the knowledge of the expert people. So the process of designing, building, and refining the knowledge base. So that knowledge base, as it requires the expert advices, so building of designing of the knowledge base, building of the knowledge base, as well as updating of the knowledge base as and when it is required, all the three combiningly we can say it is called as knowledge engineering technique. And who is responsible for this knowledge engineering technique? Knowledge engineers. Now, what do you mean by resolution? Resolution is a rule of inference in logic which is used to derive the conclusions by refuting the negation of the whole. It is a key method in automated theorem proving. So, resolution in which already we know that in our first order predicate logic we used to use all the connectives like and connective or connective negation as well as implication. Even we used to use double implication, and as well as we used to use the quantifiers like for, all, or their edges, right? So if the situation is too complex or the problem statements are too complex or the rules or facts are complex, then in that case we can go for resolution. The resolution is a kind of inference technique. Inference technique means which can derive some answers by considering the rules and facts and by avoiding the negation, refuting the negation. Especially resolution is related to removing the negation from our statements, and then it derives the result. In that case, you can go for like first we have to represent all the knowledge using first order predicate logic, means like your normal predicate logic, then consecutive normal form, disjunctive normal form, then we'll go for resolution where the negation can be avoided. So this is all about for all these definitions and terminologies related to beyond classical search. I hope you might have understood all the definitions. And for the preparation of this video, I have referred this first book for Heuristic for Artificial Intelligence. And for your reference, I kept this picture on the screen, which is available on the Amazon website. So thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.